Audio Jungle.
Good morning, everyone. We are about to discuss the lesson 2 of quarter 1 module 3. And it's all about inserting arithmetic means. The following are objectives for today's lesson. Number 1, define arithmetic mean. Number 2, identify the common difference of an arithmetic sequence given two non-consecutive terms. Number 3, solve problems where n is unknown using a sub n is equal to a sub 1 plus the quantity of n minus 1 times t. And number 4, determine the arithmetic means of a sequence. Examples. Find the missing terms in each arithmetic sequence. Number 1, 5 blank 15 blank 25. Now, what is the term between 5 and 15? 10 is correct. And the term between 15 and 25 is 20 is correct. And for number 2, negative 1, negative 5, blank blank, negative 17. What is the rule for this sequence? Yes, that is correct. The rule is by adding negative 4. If the rule is by adding negative 4, the next term after negative 5 is negative 9. Then, negative 13. What about number 3? 15 blank 27 33. The rule is just by adding positive 6. Then, after 15, the next term is 21. And for the number 4, what is the rule? 49, 42, blank 28. Yes, the rule is by subtracting 7 or adding negative 7. So 49 minus 7 is 42. Then 42 minus 7 is equal to 35. And lastly, 35 minus 7 is 20. And for number 5, we simply subtract 1. So, negative 1 minus 1 is negative 2. Negative 2 minus 1 is negative 3. Now, what do we call with these numbers? So the missing numbers in a sequence or in an arithmetic sequence are called, so these terms are called arithmetic mean. And arithmetic mean are terms between any two non-consecutive terms of an arithmetic sequence. Example, insert two arithmetic means between 5 and 17. So, list down first the terms of the given sequence, and you are asked to insert two arithmetic means. So, therefore, after 5, there are two missing terms before 17. So, the given are a sub 1 is equal to 5, a sub 4 is equal to 17, and n is equal to 4. And you are asked to find a sub 2, a sub 3. And before finding that, of course, you have to identify first or find the common difference of the given sequence. How do we do that? Okay, since a sub 1 is equal to 5, use the formula of an arithmetic sequence or finding the end of an arithmetic sequence, which is a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Plug in 5. So, a sub 4 is equal to 5 plus 4 minus 1 times d. But a sub 4 is equal to 17 equals 5. 4 minus 1 is 3 times d is 3d. Then simplify by transposing 5 to the left. That is equal to 17 minus 5 equals 3d. Then find d. So 17 minus 5 equals 12. Divide both sides by 3. Then d is equal to 4. Now that we have already found the common difference which is equal to 4, so therefore the next term after 5 is 9. Then 13. So 9 and 13 now are the two arithmetic means between 5 and 17. Next example, insert 3 arithmetic means between negative 3 and 17. So this time, the terms of the given sequence are negative 3 and the 3 unknowns, and last term is 17. How many terms are there? So there are 5 terms, so therefore that the value of n is equal to 5. First term is negative 3 and a sub 5 or the last term is equal to 17. So once again, you have to find the 3 arithmetic means, and before finding those arithmetic means, you have to determine first the common difference of the given sequence. So plug in negative 3 on the formula. A sub n is equal to a sub 1 plus the quantity of n minus 1 times d. So a sub 5 is equal to negative 3 plus 5 minus 1 times d. But a sub 5 is equal to 17 equals negative 3 plus 4d. Then 4d is equal to 17 plus 3 equals 4d equals 20. Then divide both sides. D equals 5. So therefore that the common difference is equal to 5. Then insert now the 3 arithmetic means. So negative 3 plus 5 equals 2. Then 2 plus 5 equals 7. 7 plus 5 equals 12. Okay. There's another way in finding the 3 or finding the arithmetic means of the sequence. Okay, once again, let's take all the data given. Okay, this is another way of inserting arithmetic means. So first, find D. And to find D, let us use this formula. D is equal to a sub n minus a sub k all over n minus k, where a sub n is the last term, a sub k is the first term given, and number of terms, k indicate kth term. Okay, D is equal to, remember that a sub n is the last term, a sub k is the first term in the given sequence, and n is the number of sequence, or number of terms rather, and k is the kth term. So let us now substitute the following data on the formula. A sub n is equal to 17 minus a sub k is negative 3 divided by n is equal to 5 and k is equal to 1. Simplify. D is equal to 20 divided by 4. Therefore, that D is equal to 5. So once again, since D is equal to 5, add 5 to the first term gives us 2. Then add 5 to 2 to get the next term, which is 7 plus 5 equals 12. The third and the ninth term of an arithmetic sequence are negative 5 and 25 respectively. Find the sixth term of the sequence. Write down the given. A sub 3 is equal to negative 5, a sub 9 is equal to 25. So here we are asked to find the sixth term of the given sequence. So a sub 6 is unknown, and of course we have to find first the common difference. Using a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. So take the third term. A sub 3 is equal to negative 5 and n is equal to 3. So the common difference is 5. Plug in the values. Negative 5 is equal to a sub 1 plus 3 minus 1 times d. Then we have negative 5 equals a sub 1 plus 2d. Let's call it equation 1. Next, take the ninth term, and a sub n or a sub 9 is equal to negative 5, n is equal to 9, and d is to find. Plug in 25 is equal to a sub 1 plus the quantity of 9 minus 1 times d equals 25 equals a sub 1 plus 8d, and call it equation 2. So since we have two equations, let's solve it by elimination method to find d. 25 is equal to a sub 1 plus 8d, and negative 5 equals a sub 1 plus 2d. Okay, this time, let us subtract the two equations to eliminate a sub 1. And that is equal to 25 minus negative 5 equals 30. Cancel a sub 1. And ad minus 2d is equal to 6d. And divide both sides by 6. Therefore, D is equal to 5. Then, find the first term. We have negative 5 equals a sub 1 plus 3 times 1, times 1. Minus 1 rather, times 5 equals negative 5 equals a sub 1 plus 10. Then a sub 1 is equal to negative 15. Then since we have already the first term, let us find the sixth term. So a sub 6 is equal to negative 15 plus the quantity of 6 minus 1 times 5. Then a sub 6 equals negative 15 plus 25. Simplify, the sixth term is equal to 10. Let's take the other method to find the sixth term of this sequence. So the given once again are a sub 3 equals negative 5 and the ninth term is equal to 25. So you are asked to find the sixth term, but the common difference is not given. So use this formula. D is equal to a sub n minus a sub k divided by n minus k. So D, a sub n is 25 minus a sub 3, which is negative 5, all over the ninth minus the third term, gives us 30 divided by 6, then D equals 5. So to find the sixth term, find first the first term. So plug in negative 5 is equal to a sub 1 plus 3 minus 1 times 5. So we are now looking for the first term. Then negative 5 equals a sub 1 plus 10. Then a sub 1 is equal to negative 15. Then find a sub 6 since we have already the first term. So a sub 6 is equal to negative 15 plus the quantity of 6 minus 1 times 5 equals negative 15 plus 25. Then therefore that the sixth term is equal to 10. That's the final